Hello, welcome all my dear student of TYBSc class. In previous lecture we have studied Newton-Raphson method and problems related to Newton-Raphson method. And in this lecture we are going to see algorithm for Newton-Raphson method. This algorithm is based on the discussion of Newton-Raphson method which we studied in previous lecture, as well as this algorithm is also based on an illustrative example which we studied in previous lecture. And from the discussion of Newton-Raphson method and illustrative example, we can develop an algorithm for Newton-Raphson method. There are two assumptions when we are going to develop algorithm. We should keep two assumptions in our mind. First assumption is function f of x and first order derivative of that same function given x, or we can say that the function f of x and its derivative is predefined to the compiler. Okay. Second assumption is that correct value of initial approximation is entered which satisfies the condition f of x0 into f double dash, that is second order derivative of the same function is greater than 0. That means what? The correct value of initial approximation which entered in the interval that should be satisfy the condition. Then and then the root lies in that interval. Okay. Now we are going to see the algorithm. In the first step of algorithm, read the approximation step first. Read the approximation x0. Also read the number of iteration. How many iterations should be taken, that should be written. So that should be read in the first step, and in first step also initial approximation should also be read. Now in step 2 we have to calculate, in step 2 calculate f of x or f of x0 of f of x at x is equal to x0. Okay. And also second order derivative of the same function, that is f double prime of x of 0 is equal to f of x0. Okay. x2, not x0. Okay. Now in third step third, what we have to do? In step third we have to take the net approximation, or in step third net approximation can be obtained by using the Newton-Raphson formula, x1 is equal to x0 minus f of x upon f prime of x0, not only. Okay. This is Newton-Raphson formula for first approximation, or we can say that in step 3 net approximation can be obtained by using this formula. Okay. Now after obtaining the first approximation, in step 4 we can replace what? x0 by x1. Okay. This is for the next step. Replace, say, or simply we can for next step. We can write for next step we can replace x0 by x1. And in step 5 we have to repeat step 2 to 4. We have to repeat both this step and this step. Okay. In step 5 or further iteration we have to repeat the step 2, 3 and 4. until the given number of iteration can be completed. If there are 4 iteration, then we have to repeat the step 2, 3 and 4 times. Okay. Or we can say that repeat the step 2 to 4 until value of root repeats up to given number of significant digits after decimal place or after decimal point, which we studied in the illustrative example before this. Okay. Then if that means we have to repeat step 2 to 4 until the value of roots repeats up to given number of significant digits after decimal points. Now in step 6 of the algorithm, approximate value of root x1 obtain x1 obtain. Okay. In last iteration. Then in step 7 display the root, and in step 8, that is last step, stuff. In this way, this is very simple algorithm. This is a very simple algorithm for Newton-Raphson method. That means what? A very simple procedure in order to obtain the root of given equation by using Newton-Raphson method. Or in a single word, we can say that this is the recipe for obtain the root of given equation by using Newton-Raphson method. Okay. Now, the picture we are going to see flowchart for Newton-Raphson method. Flowchart for, and we know very well, flowchart is nothing but the pictorial representation of the algorithm or graphical representation of the algorithm. So, in the first step, suppose this is start. Okay. Then here first step is shown, graphically shown, that is read initial I. Initial approximation, read initial approximation, that is x0 and number of iteration. Okay, number of iteration. Then calculate in next block. What do you have to calculate? This. That means we have to calculate there. X is equal to x0 minus f of x upon f prime x0. Okay. Sorry, not here. In second block here, we have to this calculate. We have to calculate what? Here calculate f of x0 and f of x1. Okay. And then in third step for graphical representation, here x is equal to, calculate x is equal to x0, sorry, x1 is equal to x0 minus f of x0 upon f prime of x0. Okay. Then repeat procedure for next iteration, that is n is equal to n minus 1. Then take the decision. If n is less than or equal to 0, if yes, then go to this step. Okay. if no, then go to and repeat the procedure 1, 2, 3, step 3, 2, 3 and 4 until the desired root is not obtained, or we have to repeat the procedure until the value of roots is repeated up to the significant digits after decimal point. Okay. And if yes, then what we have to do? We have to take the root of x1. Root is equal to x1 and then display the root. And after then stop. In this way, a very simple flow chart is there. We have to show the line of flow properly. Okay. Now, we are going to see the simple program for Newton-Raphson method. The program for bisection method and Newton-Raphson method are nearly same, not exactly same. There is a minute changes in Newton's Raphson method. See program for Newton-Raphson method. See here, in order to prepare the algorithm, flowchart, not flowchart. In order to prepare a program for Newton-Raphson method, we have to include standard input output header file on current path. We have to include standard library file which is header on current path. We have to include cuneo.h, that is cuneo header file. We have to also include the file math, which is header file on current. We have to include all these files. Otherwise, program, when we not include the mathematics file or the file regarding mathematical operation in current path, then compiler should puzzle or confuse, and it takes more time to bring the file from library of C. So, it is better to include all the file in current path. Then here also we have to define both function x or this function f is nothing but 4 into x into x into x 3 times. Okay. Minus 1 or minus x minus 10. Okay. No, x. Same function is defined in bisection method also. Now here again we have to define one more function for derivative, that is d of x is equal to, d of x is nothing 4 into x minus 1. Okay. Then as usual void main. Actually program begins from here. Then the body of main program. Again here define the variable which is of floating type x0, then x1, then error is equal to 0.001. Okay. And also f1 and d1, that is function first function and derivative of second function. Define all these things before the at the beginning of. Now use CLR SCR function for clearing the screen, then enter a value through keyboard a single value whose roots is to be determined, because this is open ended or extrapolation method. Hence here only one value should be provided. In close ended or in interpolation we have to supply two values, x1, x0 and x1. Here open ended method, here only we have to supply only one value, that is x0. So printf function is used, enter the value of x0, that value which provided by the user to the computer through keyboard, that value should be written or should be read by the computer through the function scanf %f, because the variable is floating type, then ampersand x0. With the help of this function, computer can read the value which is supplied by the user to the computer. Okay. Then f1 function should be calculated, f of x0. Okay. Then derivative of the first function, that is first order derivative, d of x0. Okay. Then use the formula x1 is equal to x0 minus f of x0 upon f of x1. Or instead of this we simply write not x0, f1 for function and derivative of the first function. Okay. Okay. Then use while loop. So while in bracket fabs, and in this fabs function of x1 is less than or equal to e. Okay. Here two brackets are essential, one for this and other for this. Okay. And in this the body of while is in that function, sorry, in bisection method we use do while, here we use while do. So x0 is equal to x1, then f1 is equal to d of f1, sorry, f0 derivative of, correct. Then this is the first function, correct, sorry, function, given function. Okay. Then d1 of this function, or we can say that, sorry, 0 not 1. Okay. Here when condition is first iteration is okay, first approximation is perfectly selected, then replace 0 by x1 and again use the formula, we calculated f1, calculated d1 for next approximation, and then next approximation is x1 is equal to x0 minus f1 upon d1. Okay. And in this way this while loop is completed, and after the completion of iteration print the result or the given root, the root of given equation, root of given equation is also floating type. Therefore given equation, that is x1 is equal to percentage f, because root is also floating type and the root is stored at x1, then get ch and complete. In this way the simple program is, there is a simple program for, it is need not necessary to mug the program, you can prepare the program, because this is very simple program. If you understood the proper procedure or if you are aware about algorithm and flowchart, then you can easily prepare the program for Newton-Raphson method. And when this program is executed, after the execution of the program, the message displayed on the computer screen is like that, that is output of the program is first enter the value of x0. Suppose you enter the value 2. Okay. Then second meshes, it gives the direct answer, that is the root of given equation, that is this meshes given equation x1 is equal to 1.855585. This is the desired answer or desired root of the given equation. In this way, we studied method of, or we discuss about the method of Newton-Raphson method. We see the illustrative example for, we studied the illustrative example for Newton-Raphson method. And on the discussion of Newton-Raphson method and from illustrative example, we develop the algorithm, and from the algorithm we draw the pictorial or graphical representation of algorithm, that is nothing but flow chart, and then we prepare and study the C programming for Newton-Raphson method. Now in next lecture we are going to see the last topic of this chapter, that is integration. Till then we shall stop here. Have a good day. Thank you.